Okay, we're going to jump right into finding the zeros of a polynomial, and we need to start out with the definition of a rational zero theorem. So this is getting us a starting point. So I would pause the video to read this definition real quick, but some students call this finding your P's and Q's. You start out by finding the factors of the last term called the constant term, and then find the factors of the first term called the leading term, and then you find all the different combinations of P over Q. So pause this video and take a look. Okay, so we're going to start with an example. So this polynomial right here, we want to start by finding the P's and Q's. So the last term is 9. That's going to be representing your P. And the first term is a 1. Basically, you don't see anything, so that's a 1. So if I write down all the factors of P, that's going to be plus or minus 1, 3, and 9. And then if I write down all the factors of Q, they'll be plus or minus 1. So if I write down all the different combinations of P over Q, I just take all of the P values and put them over Q. So that's 1 over 1, 3 over 1, and 9 over 1. So that's going to be plus or minus 1, 3, and 9. So this is our starting point, right? I'm going to use these numbers to try to find a zero that works for this polynomial. So what you do is you plug each one of these values into the polynomial and see if it gives you a zero. So you would plug it into your calculator, put the f of x into your y equals, and then check your chart with each one of these numbers. So you go 1, -1, 3, -3, 9, -9, and try to find something that gives you a zero, right? So the first number that gives you a zero out of this list is -1. If you plug -1 into your x value, all the x values, you're going to get 0 back, and that works. So what we do with that number is we take -1 and we do synthetic division on the polynomial. If you need a video on how to do synthetic division, you can find that in the description box. But I do my synthetic division. And this synthetic division should have a remainder of 0 because you know that it's a solution. So this is what I get, right? Then you go back and you try to find another 0 that works, and none of the other numbers work. You try 3, -3, 9, -9, and none of them work, right? And we try to, let's see. Since none of those numbers work, what we're going to do is write down our polynomial, right? Since we did synthetic division once, the new polynomial is going to be down 1 degree. So it starts with x squared. So I have x squared plus 2x plus 9. And I set that equal to 0. So I need to figure out how in the world am I going to solve this? You can't factor it, I'll tell you right now. So we're going to jump right into quadratic equation or quadratic formula. If you need a video on quadratic formula, I have that in the description box as well. So that is our faithful life-saving formula, -b plus or minus square root b squared minus 4ac all over 2a. And I plug in my ABC and I'm trying to condense as much as possible. So if you follow along in this video, you're going to see me try to simplify because I'm trying to get those last two values. If you notice, the degree of the beginning polynomial was a 3. That means I'm looking for 3 different x values, right? And they don't always have to be different. So let me not say 3 different x values. Some of them could be repeating, but we're going to go through and simplify this. I get negative square root -32. That tells me that I'm going to get imaginary numbers, and that's fine. That means I have complex solutions. So if I take -16 times 2, I know the negative is going to come out and make an I because that's what creates an imaginary number. And then I can take the square root of 16 out. That becomes 4. So I have -2 plus or minus 4 square root 2I all over 2. And if I simplify, everything outside the radical can be divided by 2, and this will be my final two x values. They are both complex. So I get x equals -1, x equals -1 plus 2 square root 2i, and then -1 minus 2 square root 2i. So let's try another example. So if we start fresh, let's put another example up. F of x equals 3x to the 4th plus 5x cubed plus 25x squared plus 45x minus 18. So I know I'm looking for 4 x values because the degree of the polynomial is 4. So let's start with our p's and q's. I got plus or minus 1, 2, 3, 6, 9, 18. These are all the factors of 18. And then the leading term is plus or minus 1 and 3. So if I find all the different combinations of p over q, I'm going to take all of my p values and put them over 1. So that's 1, 2, 3, 6, 9, 18. And then I put all of my p values over 3. So that's 1/3, 2/3. And then the 3 over 3, I already have that. 6 over 3, I have that. 9 over 3, I have that. And 18 over 3, we have that already. So I don't need to rewrite that. So this box is the values I can use to try to find a number that works. And when I say works, that means you put the value into the polynomial and it should give you 0 back. The first number that works when you plug it into your calculator is -2. If you put -2 in there for all of the x values, you get a 0 back in return. So I do synthetic division with -2 because it works. And when I do synthetic division, I should get 0 back. Again, if you need a video on how to do synthetic division, I will have that in the description box. Okay, so as we go through, I end up getting a remainder of 0, which is perfect. That means it works. And so I go back to my calculator and I try the other p over q's. And when I do, I end up getting 1/3. Positive 1/3 works as well. If you put positive 1/3 in for all the x values, you get 0 back. So I'm going to do synthetic division again. And when I do synthetic division, this will be on the new polynomial that I had, the 3, -1, 27, and -9. So notice this one gives me 0 as well. So after that, I go through and I check the rest of the p's and q's and nothing else works. So I have to write my new polynomial and notice how it starts with x squared. That means I did synthetic division twice because it broke down my degree twice. And at this point, I need to solve for x. So I move the 27. I'm going to divide by 3. And then I get x squared is equal to -9. Taking the square root of both sides to get rid of the square, that's going to give me x is equal to plus or minus 3. And because there's a negative underneath there, I got 3i. So if you notice, that's two different answers right there. So I have -2 as my first answer, -1/3 is the second one, and then I have 3i as my complex 0, and then I have -3i as my other complex 0. I hope this has been helpful.